Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about Ohm's law. Right, so let's start off with the following. Here is a fixed resistor. So this is my fixed resistor. And I want to investigate now the relationship between current and voltage for this fixed resistor. First of all, I've got to put it into a circuit. So here is my fixed resistor placed into a circuit. You've got to be familiar with the setup because it's needed to investigate current and voltage for various different components. But it's dead easy. So I'll label the different parts. Here you've got a power supply. You've also got an ammeter. You've also got a variable resistor. Resistor. And you've got the fixed resistor over here. Here we go. Here is the fixed resistor. Okay, so we'll just move it across a bit. Now, to measure the current, obviously the ammeter is placed in series with the fixed resistor. To measure the voltage, I place the voltmeter around the component I'm looking at. Because I'm looking at the fixed resistor, the voltmeter is placed around that component. So here is our voltmeter. Okay, so that's our voltmeter. Now, I'm going to change the current in that circuit. How am I going to do that? I'm going to use the variable resistor. So the variable resistor is going to be used to change the current. And we're going to take measurements of the voltage and current from that. So the variable resistor, we will change. So we're going to change the value of the variable resistor and we're going to measure values of current and voltage from the ammeter and voltmeter respectively. So I'm going to take down readings of the current from the ammeter, take down readings of voltage from the voltmeter, and we're going to look at them and see what happens. Right, so here's our results. Let's say I do that entire practical. For the fixed resistor, I end up with the following. A straight line graph going through the origin. So this is going through 0, 0. What does that mean? That means that we can see as the voltage increases, the current is increasing uniformly. Therefore, these two quantities are directly proportional. So we know that voltage is directly proportional to the current. It's directly proportional. Why? Because it's going through the origin. It has to go through the origin for it to be directly proportional. So this is known as Ohm's law. That voltage is directly proportional to the current, but provided that the resistance in the circuit remains constant. So voltage is proportional to the current. That's it. So therefore we get another relationship. That's my symbol. That symbol over here is proportional. I can therefore say V is proportional to I. Then I can move from the proportional sign into an equal sign by using the following. V is equal to I times by R. This is Ohm's law's famous formula. Voltage is equal to current times by the resistance. And that only works if they are directly proportional to each other. Why? We can see that the constant in this case is the resistance. This is my constant. Just like in maths, y is proportional to x, therefore y is equal to kx. It's the same thing here. So, Ohm's law, voltage is proportional to the current provided the resistance is constant. Provided the resistance is constant. And we end up with the formula V is equal to I times by R. Right, so here it is. Let's just remove that dirt over there. V is equal to I times by R. Let's write it out again. V is equal to I multiplied by R. Units now. We know that the resistance is going to be measured in ohms. It's a symbol you haven't come across, but here's our symbol. Omega. Yeah, make sure we can memorize that. Current is going to be in amps. And voltage is going to be measured in volts. The units of each one of them, amps, capital A, volts, capital V. So V is VA and omega. V is equal to I times by R, and our units for voltage is volts in capital V, Our units for current are in amps, capital A. Our units for resistance are ohms in the symbol omega. Right, let's see if we can actually use this formula, and you've got to memorize that for the GCSE in our next, the next part of my lesson. Right, so here we go. Test your understanding. If there are 7 amps running through a 3 ohm resistor, what will the voltage be across the resistor? So let's start. If there are 3 amps running through the 3 ohm resistor, what will the voltage be? So we know voltage is equal to current times by resistance. So voltage is therefore equal to the current, 7 amps, times by the resistance, 3 ohms. 7 times by 3, the voltage is therefore going to be 21, and the unit volts. Wonderful. Good stuff. Test your understanding again. So now if there are 10 volts across a 5 ohm resistor, what will the current be? So we know V is equal to I multiplied by R. Every time we do these problems, you always write down the formula. It's 1 mark given to you for that. Then I is equal to V divided by R. Therefore it's 10 volts divided by resistor, 5 ohms. Yes, that voltage over there, resistance over there. Therefore 10 divided by 5, we're getting 2, and the units for current, it's going to be amps. Well done again. Another tick. Right, so to summarize, the voltage current graph for a fixed resistor is a straight line graph going through the origin. Yeah, check that out. So if we're over here, we obtain the straight line graph for, this is only for the fixed resistor. Only for the fixed resistor. Okay, so we're here. Ohm's law states that voltage is directly proportional to current, provided the resistance remains constant. We also know that V is equal to I multiplied by R, where V is the voltage measured in volts. Current is represented by I, and that's measured in amps, capital A. Resistance is represented by R, and that's measured in ohms with the symbol omega. And that's it for today's session. I shall see you next time for more GCSE physics with me, Mr. Ceerazz. Goodbye.